My name is Shalini. Today I am going to talk about magnetic circuit. The definition of magnetic circuit is made up of one or more closed loop paths containing a magnetic flux. The flux is usually generated by permanent magnets or electromagnets and confined to the path by magnetic cores. There are three types of magnetic circuit: magnetomotive force MMF, magnetic flux, magnetic reluctance. The operation of MMF is strength of MMF is equivalent to the product of the current around the turns and the number of turns of the coil. The magnetic flux of the operation is through a magnetic component is proportional to the number of magnetic field lines that pass through the cross-sectional area of the component. The operation of magnetic reluctance is analogous to resistance in an electrical circuit, although it does not dissipate magnetic energy.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Firdaus bin Masnan. I want to explain about the series magnetic circuit. Okay, how to calculate the area of yoke is 2.5 times 2.5 equals 6.25 cm square. For base yoke equally to the flux divided A yoke equally 4 power of negative 4 divided 6.25 power of negative 4, we can get 0.64 T. The H yoke we can get 410 AT per M. Okay, H yoke from the table. The plunger for the area plunger 2.0 times 2.5, we can get 5 power of negative 4 m square. For the B plunger, the flux divided by A plunger 4 power of negative 4 divide 5 power of negative 4, and we can get answer 0.8 T. For the H plunger, we can get 580 per M. This the equation we can get from the table. Okay, for A gap, the B gap equal the B yoke, we can get 0.64 T. For the H gap, 7.96 the power of 5 multiply 0.64, we can get the answer 5.09 the power of 580 per M. Okay, for the number of the turn of the coil is the H yoke multiply L yoke plus H plunger multiply L plunger plus 2 H gap multiply L gap. Okay, 882 plus 50 plus 2 multiply 2000 36, we can get answer 4,204 atom. And lastly, the number of the turn of coil 4,204 divided 2.5. Okay, the answer we can get 1C82 turn.
I am Muhammad Shafiq bin Mustaq. I want to explain about properties of magnetic material, magnetism, a specimen, and series magnetic circuit, even Ni. Series magnetic circuit. Core or one material constant cross section is straightforward. But for two or more sections, the process is not simple. Before finding H in any section, you need to know the flux density. To get around this problem, use try and error. Properties of magnetic material. Each atom of magnetic field moving electron constitute the atomic level current and current create magnetic field. For non-magnetic material, fields are randomly oriented and cancelled. For ferromagnetic, the field is more rigid. Magnetizing a specimen. No magnetized specimen can be magnetized by making its dominant field line up. Okay, for figure B, the current through the coil is increased, the field strength increase, and more domain link themselves in the direction of the field.
Now, I want to share with you guys the application of the magnetic circuit. One of the applications of magnetic circuits are speakers and microphones. Do you know how does the speakers and microphones work? First of all, let me explain to you the electromagnetic effects in the design of speakers. Let's say that you have a coil of copper wire and a magnet with two poles, which is north and south poles. Then when you move the magnet inside a coil of... Next, let's move to the design of the speaker. Do you ever notice the speaker have a heavy magnet attached at the behind of the speaker's cone? The permanent magnet attached is assembled with two different types of plates, which is a front plate and a rear plate with a pole piece. The green box on the right is assuming the polarity of the whole magnet. Here is the cross-section of a permanent magnet that I have showed you earlier. As you can see, there's a rear plate of pole piece of south pole magnet, front plate of north pole magnet, the air gaps between poles. As you can see from the picture, if there is a high peaking current at the input, it will produce a strong flux pattern in the voice coil, causing the flexible cone of the speaker to vibrate, then provide the audible sound. Faraday's law stated that the induced voltage, which is also known as the EMF, electromagnetic field, is the negative product of number of loops of the coil and the derivative of flux at function of time. From this